groups after I finish mentioning a few things. And then after that, I'll upload a lab exercise in the learning. So the lab exercise is meant to, it's a tutorial that will guide you on how to send weather updates to your Twitter account. So it will do it automatically. So I just want you to see how easy, I hope it will be easy. It is, and then now you can think of maybe applying it on a use case, for example. Since now it's able to send to your Twitter account, now you can use it maybe to control how you water maybe a garden. So maybe if there is no cloud, then the sprinkler should turn on. Maybe it's hot. So you'll use a weather API. That weather API will allow you to enter the city, and then it will send real time weather updates on the location you've put. So I think the temperature, the cloud. So for the exercise, you'll just deal with the clouds, but there are many other information that you can get from that weather API. So it's a simple exercise. Just learn how to do it, and then maybe if you want, maybe now you can extend it maybe to do something else. Okay. So from this poll, I see that 4 people were not able to complete the lab. So if it's possible, you can send me an email and let me know where you got stuck, or if it was an issue of time, then you can let me know so that we know how to sort it out. Because if you don't finish these labs, they are incremental. So that means if you're stuck in the first lab, then the second lab will be even more difficult. So it's good that it's better if you sort of make sure you manage to finish every lab, so that as we go on, things are easier. Okay. So I'll end the poll. So we'll start with the presentations. So for those who didn't complete, please let me know via email. And for those who completed, good job. It will count towards your coursework. I'll look at the JSON code. Now, so let me share my screen. So today, 7 minutes per group. So I use group 1. So that is the one for Joshua, David, Masiror, Ali, Derek, Brett, Papa Blaze, and Abdi. Then ICSB group 3, that is the group for Kiplel, Jerry, Kevin, Roseanne, Vanessa, Newton, Kulthum, Thomas, Isaac, Maureen, and Stephen. Then BTC, the group for Marvin, Eric, Kevin, Michelle, and Naomi. Okay, so we'll start with group ICSA group 1. So this is the marking guide that I'll use. I think I showed you. So I'll look at time consciousness, teamwork, the clarity of your explanation, and then the arguments that you have for whatever maybe choice you make. So I can see, I think there's a question. Oh, that's not BTC. Okay, BTC. Do I have the group for BTC? So if this is not BTC, then which one? Where is BTC? ICSB. Oh, okay. So ICSB group 6 is BTC 1. Okay. So that is so that should be Marvin, Eric, Ian, Ubre, Michelle, Gabriel, and Fiona. Anyway, when we get there, we'll. So let's start with group 1, ICSA. So that is Joshua. So who's ready? Joshua's group. Mhm. Is Joshua around? Yes, Stacy. Stacy, you're in group. Which group are you in?
Group 2.
Oh, group 2.
Yeah.
ICS group. This is group.
Sorry, group A, group 2.
Oh, group 2.
Yeah.
Okay, okay. I'm looking for group 1. Mhm. Joshua, yes. Joshua, you ready?
Yes,
Morning, how are you?
I'm good. Maybe.
Okay. You're ready?
Yes, I'm ready. So I'll present the first question.
Okay. You have
Then
a
the rest of
presentation or you'll just be talking?
I have a PowerPoint presentation.
So I can make you a co-host.
Yes.
Okay, sawa. So you can show your presentation and then, yeah.
So with the first question, demonstrate the difference between embedded system and IoT using a real life example. First, with the definition, embedded systems, computer hardware and software that are embedded into everyday things. They're dedicated to a particular function and are difficult to update once they're shipped. And for IoT, the computer hardware and software and networking capabilities that are embedded into everyday things. They're often updated using network capabilities and may act as a client with functionality implemented by cloud platform. For examples of IoT, we had the smart speakers like Alexa, and for embedded system, we had PS4, PlayStation 4 gaming console. Hello.
Yes. You're done.
Yeah, that was for question one.
Uh, who is presenting the next question?
Brett.
Yeah, just so you are a co-host, so unmute them and yeah, let them present.
Yes, good morning.
Morning, how are you?
I'm fine. So I'm going to go through the characteristics of the IoT and embedded systems. So I'm going to start with embedded systems. For embedded systems, we saw the following characteristics were very similar in most of them. So embedded systems are task specific, like let's say your system wants to measure some temperature or measure some particular task. Yeah, so that is one characteristic. The second one is that they have a particular time frame. Let's say, like for example, a microwave. You put some food there, and you set the time for 1 minute or 2 minutes or whatever. They don't have minimal or no user. Same example of a microwave that is very minimum to the number of inputs that you can do to the system. And the third one, we found that most of the embedded systems cannot be changed or upgraded by the user. You cannot update the softwares or the hardware yourself. You can, but it can be an easy and a hard task for you. And then we have microcontrollers and microprocessors are used to design. I think some particular semester we were working with Arduinos, and we got to design some specific systems that can control maybe light and yeah. So I'm going to move to the next one, which is characteristics of IoT. And first is the intelligent devices. Let's say like the smart speakers. The smart speakers can connect to the internet and can give you specific information on what you want. Let's say like you have an Alexa at home and you want to check the weather today without going to your phone. You just say the activation word for Alexa. I think it's Alexa. Yeah. Just say Alexa, check the weather. It will show you the weather details. The second one is most of them have some form of connectivity which allow them to connect to the internet or connect to other devices. Let's say like the Bluetooth devices that can connect to other Bluetooth devices, like your phone to your speakers, to your Alexas, to your yeah. Some of them can connect to Wi-Fi that enable them to maybe, let's say you're doing some remote programming, maybe you can connect through SSH, as you all know. And some of them have sensing capabilities, such as, let's say you're building a smart home, as there are some cameras that are around the house, and maybe you want to sense some intrusion on the house. If the cameras, let's say, pick up some particular object moving inside the house using the infrared and other forms of input, you can get to know what is happening. Interactivity, in that it is more interactive than the embedded systems, in a way that interact with them and send more inputs, such as, let's say, your smart house. You can set the temperature of the house if you are connected. If your fridge and microwaves are connected, you can maybe prepare a lunch when you are at work. You can warm your food, such stuff. Yeah. So I'll give my group members to present the last question.
Okay, I'll through the last slide, reasons to switch to IoT. Here we check the advantages that switching to IoT will have compared to having an embedded system based on their characteristics. So the first one, it will enable Adrian to build device-independent applications. So having an IoT system will give an edge over the embedded system, as the IoT systems will allow for an independent devices, unlike the embedded systems which only allow for dependent devices. The second one, it will enable Adrian to build applications with more than one functionality. So this is also a characteristic of the IoT devices that the embedded devices do not have. Then it also enable networking features. We've just seen the embedded device, the IoT devices allow for connectivity. So this is an edge that they'll have over the embedded devices, including things like Wi-Fi and Bluetooth. Then upgrading the applications will be simpler when Adrian implements the IoT devices. So the IoT devices will allow for, they have better interactivity than the embedded systems. So they'll enable the user to upgrade and have more interface with the applications than the embedded system. That's all.
Okay, thank you. So, Joshua, you're done? Okay, sawa sawa. Any question? Anyone with a question for them? Okay, so that is so group ICS group A. That was a good presentation. So let me share my screen. So that for that group, Joshua. So what I want you to do is in that your presentation, kindly add the first in the first slide, add the group members. Okay, and then send me the slide to my email. I'll give my comments on your ideas, and then I'll send it back to you. Sawa sawa. Then you have a question. There's someone asking, why did you say that PS4 is an embedded system, but it has a network access? Joshua or anyone in the group? Yes, Brett, you can answer.
Yeah, so we are saying PS4, not only a PS4, but a particular game console. The primary purpose of a game console is to play the games, and the other ones are just features. Unless anyone has anything to add.
Where is Ali Yasin? Ali Yasin is around.
Yes, I'm around.
Yeah, what is the answer to that question?
I support Brett's answer because PlayStation's function is to basically achieve the goal of playing games and all. So the network access and all are just added features to the PlayStation system. That's why it's an embedded system.
Okay. So what you're saying is that since its core task is playing video games, the network is just an addition.
It's an additional feature, yes.
So it's possible that there are PS4s that don't have network.
Okay, the PlayStation, you can achieve your goal even without connecting to the network
Okay.
for playing games and all.
But if it has a network, then maybe let me see if someone else has a different answer. Papa Blaze. If it has a network, then is it an embedded system or an IoT system? Is Papa around? Papa? Okay, Papa is not around. Derek, Musuya?
I think the network is just it's not a basic feature. Like how Chino has been saying, the PS4 can operate without the network. So the network not being a necessity, we can take it as an additional feature.
Okay. Anyway, I don't want to give hints to the next two groups that are presenting, but I think when we covered the embedded system, we talked of a network. You remember we talked of bus topology and everything. So it means that embedded systems can also talk to each other. So the bus really doesn't have to be, you don't have to think of it as wires or maybe a physical thing. The bus can be any network. It's only that the way devices are communicating. So it can be a Bluetooth bus, but the way devices are communicating is through the broadcasting. Okay. So try to think of it that way. I don't want to give more hints to the next group that are presenting. I'll give my comments to us. So we move to group B. So group 3. So Isaac, Jerry. So who's ready? Who is so the group for Isaac, Jerry, Kevin, Roseanne, Vanessa, Newton, Hassan, Thomas, Isaac, Maureen, and Stephen. So Vanessa, you ready?
Yes, I want to share my screen.
Okay, so let me make you a co-host. So so Vanessa, you'll take care of the presentation. So you call the person who presents next and so forth. Yeah? Okay, you can share supposed to your screen.
So the first person to present is Isaac. So let me just mute Isaac. Mhm.
Hello, can you hear me?
Oh, yeah.
Yes, we can hear you.
Okay. So we're looking at the differences between IoT and ECS, embedded systems. Embedded systems is a subset of IoT. What I mean by that is IoT forms like a general, like an umbrella, whereby we'll have an embedded technology in it, technology, then an information technology. Now, let's define Internet of Things first. When we talked about Internet of Things, in this case can be like anything. It can be a door, it can be a fridge, and everything. So we have to give it ability to communicate with another thing. Now, that ability can be achieved now connecting that thing to the internet, whereby to the internet or a local network, where send their data there and then communicate. Now, an embedded technology, we talked about it. It's a device that performs a specific function. Now, in this case, let's think of a winter period whereby you're leaving your home, you're leaving your office going home. Now, from your phone can automatically tell maybe that you're leaving your office work from an application that is on your phone. And then from there, it can now initiate an AC, a smart AC at your home to maybe turn on. Now, in this smart AC will be an embedded system which will now collect information like the temperatures from the sensors and then send it to the cloud. Now, that will be an embedded system. Now, the network technology, that is the Wi-Fi maybe, where we use now to communicate, or an RFID, or wireless sensor network, all those will form now the networking technology of this, because we'll have to communicate with the internet, and to do that we'll now need the network technologies. Then the mobile app infrastructure, that is the app on your phone that you can control everything on your home, maybe control your the AC, control your doors, like see whoever is got in at what is a subset of an IoT device. Yeah.
Okay, just to able to come up with is look at a pacemaker. So a pacemaker, when it's placed up, able to detect the signals and detect like the signals of the heart. That so we can say that the pacemaker is an embedded system. But when this pacemaker now is able to transmit the signals over the internet and maybe to a certain server, and then it alerts like a member of let's say a relative of the person with the pacemaker that, oh, there are abnormal signals, then it becomes an IoT device because it's transmitting signals over the internet. Yeah, over internet. So next to present is Kulthum.
So we're going to look at the comparisons of the characteristics of ECS and IoT. So for the ECS, it's single function. It's single function. That means it's able to perform, its main purpose is just to perform a specific task. While an IoT is multifunction, that means it can be able to it's able to perform many. It's basically meant for many purposes. You can say that, such that it can be able to transmit data, store data, and whatnot. For the ETS, we also have its connectivity to the internet. And then for the IoT, we talked about connectivity. This is simply the transmission of data. Okay, Thomas is going.
Yes, we can.
Designed for limited to human interaction, meaning that the ECS, it doesn't have like a UI for the user to interact with, since it's only meant to perform one task only. And for the IoT, it has a UI, like for example, a smart home system that the user can use to like change the temperature and whatnot. And the next one is difficult to update for the ECS, since it's like an isolated system. It's like a single system, since it doesn't need to be updated regularly. And updating it is difficult since, as I said, it's an isolated system. And the next one is for the IoT part, it's oftenly updated because of the network capabilities, so it's easier to update compared to CS. And the last one, it's concept to how to set up a software or hardware device. Since the ECS, it's, as I said again, it's an isolated system. Hence, when it's being set up or when it's designed, it's only like the main focus is only on that one system, since it doesn't communicate with other systems. And on the IoT part, it focuses more on how the devices communicate with each other, since an IoT device is comprised of different devices, different systems that are used to interchange like data. Yeah, that's it for the comparison. I'll pass it on to the next person.
Kevin Chemjur.
Can you guys hear me?
Yes.
Yes, we can hear you.
Okay, so for this question of Arjan's decision, we looked at it. We felt that it wasn't objective in the sense that
Yes.
it really depended on what embedded system Arjan is and what he's using. So basically, we gave two answers, or rather two comparisons for this. So you can change to an IoT device if he really wants to connect to the cloud, send data, and maybe require some predictive analysis for whatever he's doing with the embedded system. And moreover to that, we went on and class also said no, depending on what system is using. If he's just using an embedded system to just do a specific function, he'd rather just continue with his embedded system, because moving to an IoT, it might pose him issues like security issues, which might come as threats from being connected to the internet. Yeah, so basically, and also like he will add more resources, which means more cost. So yeah, that was our answer on that.
And then Newton.
Some of the advantages that we discussed if Adyen is to change to an IoT device is that for the tasks that will be taking, um, automation will make the management of these tasks more efficient, and there'll be ease to access of information remotely. And a disadvantage, or rather two, the complexity in design of IoT systems might pose a challenge in maintenance, and there is, as Chandra said, security risks that come with connecting to the internet. Yes.
Yes, that's the end of our presentation. Any questions?
So anyone with a question? Okay, so thank you very much, Vanessa. I like the group work, so that means I can remove. I like the coursework. So someone is asking, Purity Rono, can you please go to the first slide? Vanessa?
You need to give me back
Okay,
control.
okay, let me give you back.
Here is the first slide, purity.
Can you hear me?
Yes.
So this point where you're saying a smart AC will become is an embedded system. Are you sure that's the correct term? Because I believe an AC on its own is an embedded system, but when you connect it to a mobile phone, it becomes an internet IoT. So can you like clarify on that?
Okay. I can just invite anyone in my group who hasn't spoken to answer it. Roseanne, Isaac,
Yeah, there's
anyone?
Roseanne. An answer to the question?
Okay. Can you hear me?
Yes.
Yes, we can hear.
Okay. According to me, I thought just as he said, like its task, it's an embedded system. But then the moment it starts, wait, what colors and it starts to send data like that nini, oh, this is the temperature, we've adjusted it to this, it becomes an embedded an IoT system. I'm not really sure.
Okay. I've seen there are other people who want to answer, so Isaac Kiplel can add on.
Yeah. Okay. As we explained, an embedded system performs a specific task. So yeah, if it's just like an AC, it's also an embedded. Okay, it being smart. I think the keyword here is, but if you have it, like if it's just an AC that just a second, just an AC that can collect temperature from a sensor, then send it like to the cloud. As the lecturer also explained earlier, also embedded systems have some form of network topologies. So if it's just an embedded system, I think by saying a smart AC, someone will just completely an IoT device. But if it just takes this temperature sensors and then sends it to the cloud or something, that will form an embedded system. Like we've just made it smart because we just thought it's the whole thing because it will include also the network topology and even connecting it to the phone, but as in general, but just think of it as the AC itself. We haven't yet connected it to the phone and everything. Just think of the AC itself. That will form an embedded system. Yeah, that's it.
Any other questions? Hello.
Hello, there's the last question. ECS is a subset of IoT from Sam.
Okay. I still invite other people who haven't spoken so that everyone can speak. Jerry Isaac Mutanya.
Can I give it a shot?
Yes, you can, Rizan.
Okay. For me, I think that statement means that okay, like a subset is like part of. So, for example, like in the second point, IoT has embedded technology, yeah, plus network technology and information technology. But then the first one, the embedded system, like it means that it's part of an IoT, like it's just a subset, like it's just part of it. Yeah, that's what it means. Does it make sense?
Yes.
Okay, so I hope they've tried to answer your questions. I'll try to clarify on a few things after the last presentation. So now we go to the last group. So I'm told that BTC group 1 is ICS. So BTC group, so we'll go to BTC group 2 because I think that is BTC. So the one for Gabriel, Ezekiel, Ian, Ubre, and so Marvin is in ICSB.
Excuse me, sir. Just
Yes.
before your last to present, we the group 1 for BTC and the group 2 for BTC are actually group 6 for ICS.
Oh, for ICS. Okay,
Yes.
okay. So that means BTC there are some groups that there are some people who don't have groups. Yeah. Anyway. Yeah. So group 3. What about group 3? Is there Alvin, Bansi, Cyril, Lamek, and Michael? Anyone who is around? Alvin? Okay, I can see someone is chatting. Okay, so you have groups, but that list is incorrect. So this is Victor. So Victor, do you have another list? Victor, group 3 and 4 is one group. Okay, and how many groups are there? So maybe it seems you have a list that I don't have. So in that list that you have, how many groups do you have? Two groups? No, it has to be 4. It has to be 4. So I can see that group 3 and 4 is one group. Okay, but do we have Alvin, Bansi, Cyril, Lamek, and Michael? Okay. So I guess BTC has a problem. Maybe we need to sort it out later. Now, if for BTC, if you don't get a chance to present, most probably you won't get another chance, and you'll miss on marks. I don't think I'll give you maybe another chance to present. So you'll miss out on the presentation marks. Now, just to comment on now the first two presentations. For group 2, please on the second slide or first slide, add the list of all your members, and then you can send me the PowerPoint so that I can put my comments, and then I'll send it back to you guys. Okay. So the first two questions in this case study are mainly trying to get you to differentiate between an embedded system and an IoT system. Now, the way I will go about it is, first of all, just look at the components of an ECS and the components of an IoT. They are the same. Okay. So for an ECS, you must have a sensor, actuator, microprocessor. Okay. The same for the IoT. The only addition for the IoT is that you must have a network component. Okay. For the ECS, the network is it's sort of not very important. It's sort of just optional. But for the IoT, there must be a network component. So you can see there's someone. What a question. The sort of a network. So from there, you realize that as a group two was saying, ECS is sort of like it's like an IoT system that maybe has less capability. Because if you look at the characteristics, you realize that for the IoT, we emphasized on smartness or intelligence. Okay, so that is being ubiquitous, being able to sort of almost think on its own, and we didn't emphasize that on the embedded system, on the embedded computing system. Okay, the other thing in the characteristics was the analytics. So for the IoT, there's a lot of analytics. So that means that data has to go to a cloud somewhere. It has to be analyzed. So maybe data mining or learning or trying to predict something. So these two characteristics sort of, it's like adding some brain to an embedded system. So instead of it just being able to collect sensor data, you sort of allow it now to use that data to maybe become more smart, or you actually collect that data and analyze it and maybe use it now to control something else from an analysis point of view. For an embedded system, you can think of it as it's able to perform a single function, but it's sort of local. So the only things it can communicate with are maybe things that are sort of near it. By near, I don't mean it physical, but the network itself. It's not meant to go maybe to the cloud. Okay, so by local, I mean that there's no cloud involved, sort of. Okay, so you can think of it that way. So the IoT, just the smartness and the analytics and the network. You see, the IoT, the network is much more intensive. So it allows not only bus, but any other type of network, and it can allow, as in the device can send it has so many options of sending um, information. I don't know if it's clear. Okay. Then the last question, should Adrian convert his ECS application to an IoT application or not? So this one, there's really no yes or no answer. It just depends on your justification. So I think both groups tried, but the argument for group three, ICSB group three, it made more sense because they looked at both scenarios. I think group ICSA just looked at one scenario. Group three looked at both scenarios, which I think was a good way of answering that question. Yes. So any questions so far? So I'll upload the lab work in a few minutes in the e-learning. So it will help you to try to connect to an API, a weather API that will give you real-time information about weather on any location in the world. So you just pick a location. So for example, just try to pick where you live, and then it's supposed to send that data to your Twitter account. So you'll have to create an API on your Twitter account. So the tutorial will show you how to go about it, and then you'll upload the JSON to the learning. Okay. Yes, that is the end of the presentation. BTC, you need to sort out you need to do some skipping, because I think I remember I told you to send me an email with the groups. So I don't think I got an email with the correct groups. So you guys, you're going to miss out, and I'm not going to give you another chance to present. Okay. So we'll stop there, and you guys have a nice day, and enjoy the rest of the day.